Pultrusion is a manufacturing process that converts fiber reinforcements and resin matrices into finished composite parts. Unlike other processes, pultrusion enables continuous production in a highly automated and low-labor process that uses a heated die to give shape to the composite part. In pultrusion, carbon and glass or Kevlar fibers are stretched out while being impregnated with a mixed resin and hardener and are cured at both room temperature and high temperature to produce fiber-reinforced plastic products. This lecture is part of the series prepared by TE&MC on the topic of manufacturing techniques in fiberglass and carbon fiber composites. Pultrusion products include construction items. It is also very popular in sports industry. Few examples are flashed on the screen. The term is a portmanteau word, combining pull and extrusion. As opposed to extrusion, which pushes the material, pultrusion pulls the material. Although primarily open at the fiber entry stage, pultrusion molds close during curing to form continuous cross-sectional profiles. This technique is popular among manufacturers of composite structural items like beams, channels, and rods. Pultrusion is a continuous process of roving or roving bundles, which are drawn through a resin-impregnated bath to coat each fiber with a specially formulated resin mixture. The impregnated fibers are then drawn through a heated die, which forms the desired cross-section. This process is popular for producing carbon fiber products that allow high strength-to-weight ratio. Critical non-reactive pultrusion process parameters that strongly affect the production process are flashed on the screen. These must be carefully finalized before start of production to obtain best and consistent quality products. This process has the capability for round-the-clock manufacturing, hence, allowing high production rates. Pultrusion process is versatile enough to accommodate various types of resins. These include polyester, epoxy, phenolic and polyurethane resins. This allows liberty of choosing wide variety of finished items for commercial as well as aerospace industries. However, polyester is the most frequently used pultrusion resin in the composite manufacturing sector, accounting for 75% of all pultrusion resins. The pultrusion process is the only FRP process which has to use an internal mold release agent. At times problems may occur with surface finish, adhesive bonding, and rapid die erosion. In order to accommodate this, the development of a new generation release agents other than zinc straight has made very good progress. These may include fatty ester, silicones, and metallic soaps. You aren't just going to head out to the backyard and do a little hobby-scale pultruding. Pultrusion requires specialized training before setting up the manufacturing unit. It is a complex process requiring in-depth knowledge of the subject. Dies that form and cure the finished profile are expensive and must be carefully designed. Extrusion pushes material through a die, whereas pultrusion, as the name suggests, pulls the material through. Pultrusion utilizes composites that are reinforced with long strands of fiber, such as carbon, Kevlar or glass, and a resin. Pull forming allows for some variation to be introduced into the cross-section. The process pulls the materials through the die for impregnation, and then clamps them in a mold for curing. This process allows for the creation of high-strength, lightweight composite products with consistent quality and properties. Production rate is high due to the possibility of continuous production. Important web links related to technology education and mentoring center are flashed on the screen. More lectures describing various manufacturing techniques for fiberglass and carbon fiber reinforced products will be uploaded on our YouTube channel in coming weeks.